Alright, so here I'm going to go over some practice problems with dividing polynomials, just in case you needed extra help on any of these U-track questions, or if you just wanted to hear me talk more. We're going to just try to simplify these as much as possible by dividing the denominator into all the terms in the numerator. So I'm going to split this up into two separate fractions. And I'm going to keep the denominator the same. All I did was keep the sign in between those two and split it into two separate fractions, so that I can then use laws of exponents to simplify each of those fractions separately. I'm going to divide 5 divided by 5. That's just 1. I'm not even going to write that. I'm going to write x with a new exponent of 1 because I'm subtracting 2 minus 1. And y with a new exponent of 3 because I'm subtracting 4 minus 1. Minus, that sign is going to stay the same. 25 divided by 5 is 5. And I subtract the exponents for both these. These both have exponents of 1, so I get x to the 4th and y to the 6th. Same logic on the next one. I'm splitting that into three separate fractions. 3x to the 5th y squared divided by 3. Messing that up. 3x squared minus 9x to the 3rd z divided by 3x squared plus 6x squared z to the 3rd divided by 3x squared. So on each of those I'm going to use exponent rules to simplify. That turns into 1x to the 3rd y squared. Nothing changed the y. All I did was divide my coefficients and subtract the exponents. Again, divide the coefficients, that's negative 3. Subtract the exponents, that leaves me with x to the 1st, and nothing touched that z to the 1st. I'm going to write that still as z to the 1st. One more time, divide the exponents, dividing the coefficients and subtracting the exponents. X squared divided by x squared is really x to the 0th power. That turns into 1, not x to the 1st, but it turns into the whole x to the 0th power turns into a 1. So basically nothing's left. I'm really multiplying 2 times 1 times z to the 3rd, but I don't really need to show that 2 times 1 because that's just 2. It turns into 2 z to the 3rd. That is as simple as that gets because none of those are like terms. So this one is talking about the area of a rectangular yard, and it's represented by that. The answer to length times width is that area. So I'm really going to work backwards on that equation. I'm just going to simplify this by dividing each of those by 3xy. So 6xy squared divided by 3xy minus 9x squared y squared divided by 3xy. Divide the coefficients. And you subtract exponents. These completely cancel out. This leaves me with just 1y. And then 9 divided by 3 is 3. X squared divided by x leaves me with just an x. Y squared divided by y leaves me with just y. So that is the length of the rectangular yard. This length times the width that they gave me would give me the area that they also gave me. Now I have to factor some stuff so that I can cancel out the common factors. Something that's on the top and on the bottom can be canceled out completely. When you factor this, you're looking for something that multiplies to be 24 and adds to be 14. That has to be 12 and 2. Those are both possible. And that's not a coincidence at all because that is going to show up on the bottom. X plus 12 and x plus 2. on the top with just the x plus 12 on the bottom. The common factors there, really the one common factor, is the x plus 12. This is being multiplied times that. We're also dividing by it. That's why we're allowed to cancel out. Those are complete opposite operations. I'm multiplying by something, and I'm dividing by it. Those can completely cancel out, leaving me with just x plus 2. Same kind of logic on the next one, except now I have to factor this using grouping. I have to do a times c, which is negative 60, and I have to figure out what's going to multiply by negative 60 and add up to be b, which is negative 7. I'm going to split negative 7 into those two factors. That has to be a negative 3. No, that's not right. That's not right at all. I'm looking for something that's going to multiply to be negative 60. I'm going to list out some of the factors here. Let's do 20 and negative 3. That's 4. That's going to be negative, positive 17. 15 and negative 4. That's going to be 11. 12 and negative 5. That's close. That's going to be a positive 7. I want a negative 7. So I'm just going to switch the signs there. 12 and positive 5. So that's the combination that I need to use. I have to use a negative 12 and a positive 5, because that's going to add up to a negative 7. So I'm going to write that as negative 12 and positive 5. They both still have x's on them because they're splitting up this negative 7x. I'm basically doing the opposite of combining like terms here. And then I rewrite the rest of it exactly the same. I guess I changed blues there, but that's okay. This is all still divided by 4x plus 5. That should be one of my factors. When I simplify this completely, when I factor that, the opposite of simplifying, when I factor that completely, this should be one of the factors. I want to just keep that in mind as I do this. I'm going to factor this group as much as I can. I can divide this by 4x. I can divide this by 4x. That gives me 4x on the outside with an x still left in the middle, minus 3, plus I have to factor something out of this group to make it the exact same thing as whatever was in this group. So I have to change it into an x minus 3. That means I have to divide by a positive 5. The 5 comes to the outside, leaves me with an x minus 3 on the inside. Those need to be the same. And now I'm going to write those two factors over my denominator, x plus 5. That's coming from these two GCFs. And x minus 3, oops, x minus, I'll just do that again. X minus 3. All of that, we'll change colors. All of that is divided by 4x minus 5. So the common factor there, sorry, plus 5. The common factor there is 4x plus 5. Those cancel out, which means that this equals x minus 3. I'm going to show a slightly easier way to do that. I guess it depends on who you are, but it might be a little bit quicker. Keep in mind what you're supposed to get. What you are supposed to get from the factors of the top. I know that this is going to turn into 4x plus 5 times something. Because I know I'm going to cancel out this 4x plus 5. This is not a real math rule, but this is a good way to figure out, at least for Algebra 1, how you're going to factor that top thing. I know it's going to turn into this because that's what I have on the bottom. In Algebra 2, you're going to deal with stuff that doesn't factor out cleanly like this, so this is not really reliable, but for now, you can use this at least to try to work backwards if you can't figure out how to factor that on your own. So I'm thinking about, really, I'm just thinking about how I'm getting that negative 15. If I'm going to get negative 15 and I'm multiplying something times this 5, this would have to be a negative 3. I know I'm going to multiply these two together to get that part. So positive 5 times negative 3 would give me that negative 15. I also know that this didn't change. It's 4x and 4x squared. The coefficient didn't change, so there's no number in front of this x. That x is being multiplied times 4x to give me the 4x squared. This negative 3 is being multiplied times that 5 to give me this negative 15. So that's an easier way, maybe, for some of you, to work backwards to figure out what that extra factor has to be. I'm going to show that one more time on letter D, and then I'm also going to do D the right way. Oh, no, I can't use it on D. Sorry, we have to factor out the bottom. So we have to actually factor the top and the bottom here. I might as well just continue with that one. I'm going to factor the top. There I'm just looking for what's multiplying to give me negative 20, and adding up to be negative 8. And the A there is 1, so I don't have to do factoring by grouping. It's going to give me negative 10 as one of the factors, and positive 2 as the other. The bottom is looking for what's going to multiply to be negative 4 and add up to 0. There is no middle term there. They have to completely cancel out, and they have to multiply to be negative 4. That's going to be a positive 2 and a negative 2. The common factors there are x plus 2 and x plus 2. The top and the bottom, again, it's canceling out because this is multiplication and this is division. Those are opposite operations. If I multiply by x plus 2 and I divide by x plus 2, I don't actually need to write those at all. Those just completely cancel out, leaving me with just x minus 10 and x minus 2. On letter C, we have more than one variable, so we want to look for a greatest common factor. We're not factoring this using grouping. We're not going to factor this into two groups like that. We're looking at two separate variables, so we're looking for the greatest common factor of that. Actually, it doesn't even have to be the greatest common factor. It really just has to be that factor. Really, that's what I'm looking to factor out. I'm going to factor that out of each of those. And the way I'm showing that is just by writing my two fractions like this. The first term over 3a to the third, and b squared minus 3a to the fourth, b squared over 3a to the third. I did the exact same mistake. Should be a 3 there, b squared. So I'm simplifying each of those using my exponent rules. I divide the coefficients, that gives me 2. The a's here completely cancel out, and I subtract my exponents, that gives me b squared. Minus, that sign stays the same. 3 divided by 3 is just 1. I'm not going to write that. I'm going to subtract these exponents. That becomes a to the first. I'm not going to write that 1. You really don't need to. A and a to the first are the same. And then these b squareds completely cancel out, so I don't even need to write that part. That is my final answer there. You should be able to complete the problems on the back. Please email me with questions if you need any help on these. Some of these are written a little bit different, but they're the exact same thing. This is written as a division symbol. It's the exact same thing as writing it like that. Remember, fraction is just dividing.
Wow.